You clicked Login with Google. A new page opened. You clicked Allow. A few seconds later, you're back in your app, logged in. Simple. Except, in those few seconds, your browser, your Spring Boot application, and Google's servers exchanged multiple requests, generated random values, validated security checks, exchanged tokens, loaded user information, and established an authenticated session. Most developers ship this feature without ever tracing what actually happened. I know because I was one of them. The feature worked on my first try, and I moved on. Then one day, a teammate asked me, "What exactly is the state parameter for?" I had no idea. So I dug into Spring Security's internals, followed every request, every redirect, every filter, and finally understood what was actually happening behind that innocent little button. Welcome to Code with Clarity, where we don't just build features, we understand how they work under the hood. Today, we're following the complete OAuth2 login flow inside Spring Security, from the moment you click the button until Spring Security authenticates the user. No magic, no hand-waving, just the complete flow. Section 1. The biggest misconception. Before we trace the requests, let's clear up one misconception almost every developer has. OAuth2 is not an authentication protocol. It's an authorization framework. Its original purpose wasn't logging users in. Its purpose was allowing an application to access resources on behalf of a user. When you click Login with Google, you're not really authenticating through OAuth2. You're authorizing your application to ask Google, "Hey, can you tell me who this person is?" The actual identity part, that comes from OpenID Connect, which sits on top of OAuth2. Spring Security's OAuth2 login uses both. OAuth2 for the delegation flow, OpenID Connect for the identity token. Many tutorials blur these together. Don't. Keeping these responsibilities separate makes everything else much easier to understand. Section 2. Meet the 4 players. Every OAuth2 flow involves 4 actors. Knowing who's talking to whom makes the entire process much easier to follow. First, the resource owner. That's the user sitting in front of the browser. Second, the client. That's your Spring Boot application. It's requesting permission to access user information. Third, the authorization server. In this example, that's Google. It's responsible for authenticating the user, asking for consent, and issuing tokens. Finally, the resource server. This is where the protected user information actually lives. For Google Login, that's Google's user info endpoint. Every redirect, every token, every HTTP request is simply one of these 4 players communicating with another. Section 3. Why Authorization Code Flow? 245, 345. OAuth2 supports several grant types. For web applications, Spring Security uses the authorization code flow. The reason comes down to one simple security principle. The access token should never be exposed to the browser. Browsers aren't trusted environments. Extensions can inspect pages. JavaScript can be compromised. Browser history exists. So instead of sending the access token through the browser, Google sends something much less valuable, a short-lived, single-use authorization code. Your browser only carries that temporary code. Your backend then exchanges that code directly with Google's servers for an access token. That server-to-server communication is what keeps the access token hidden from the browser. Almost everything else in OAuth2 exists because of that one design decision. Let's trace this from the moment the user clicks the login button. Step 1. The redirect. The user hits your login endpoint. Spring Security's OAuth2 Authorization request. Redir ECT filter intercepts that request. It builds an authorization URL, pointing to Google's authorization server, and redirects the browser there. That URL carries 4 important things: your client ID, the redirect URI where Google should send the user back, the scopes you're requesting, like OpenID and email, and a state parameter, which is a random value Spring generates and stores in the session. Step 2. The user consents. The browser lands on Google's login and consent page. Google asks, "This app wants to access your email and profile. Do you allow it?" The user clicks, "Allow." Step 3. The authorization code. Google redirects the browser back to your app's redirect URI. In the query parameters, it attaches an authorization code, a short-lived, one-time use string. It also sends back the state parameter exactly as you sent it. Step 4. State validation. This is the step nobody talks about. Spring Security's OAuth2 login authentication. Filter receives this callback request. The first thing it does is compare the incoming state value against what it stored in the session before the redirect. If they don't match, the request is rejected. This is CSRF protection. Without it, an attacker could craft a callback URL and trick your server into processing a code it never actually requested. If the states match, we proceed. Step 5. The token exchange. Now your server, not the browser, your backend, makes a direct post request to Google's token endpoint. It sends the authorization code, your client ID, your client secret, and the redirect URI. Google validates all of this and responds with an access token and an ID token. The ID token is a JWT signed by Google. It contains the user's identity claims, their name, email, subject ID. Step 6. Loading the user. Spring Security now takes that ID token and calls the default OAuth2 user service, or the OIDC specific variant. It fetches the user's profile from Google's user info endpoint using the access token. From that profile, it creates an OAuth2 user object, which gets wrapped into an OAuth2 authentication token and stored in the security context. At this point, the user is authenticated. The session is established. Any subsequent request carries that session, and Spring Security considers them logged in. Section 5. Where Spring Security's filter chain fits. All of this happens inside two filters. OAuth2 Authorization. Request Redire ECT filter handles the outbound leg, detecting the login request and building the redirect to Google. OAuth2 Login Authentication filter handles the inbound leg, receiving Google's callback, validating state, exchanging the code, loading the user, and establishing the authentication. These filters are wired into Spring Security's filter chain automatically when you add OAuth2 Login to your security config. They sit before your application logic, before your controllers, before any custom filter you write. Understanding this is what separates "it works" from actually knowing what your system does. Section 6. The things that can go wrong. A few failure points worth knowing. If the state doesn't match, you'll get an error before the token exchange even begins. This is intentional. Don't work around it. If the authorization code has already been used, Google will reject the token exchange. Codes are single-use. If your server retrieves or if you're testing with the same callback URL twice, this will bite you. If the redirect URI in your token exchange request doesn't exactly match what's registered in Google's console, the exchange fails. Exact match. No trailing slashes, no port differences. And if your session is lost between the redirect and the callback, the state validation will fail because the stored value is gone. This matters in load-balanced environments where sessions aren't shared across instances. Most developers build this feature without understanding it. And it works, until it doesn't. The moment you hit a state mismatch in production, or a callback fails silently, or you need to customize what happens after login, that's when you need to know this flow. This is part 3 in a series on Spring Security internals. Part 1 covers the filter chain and how authentication works at a foundational level. Part 2 covers JWT with once per request filter. If this was useful, subscribe to Code with Clarity, where we turn complex ideas into real understanding. See you on the next one.